Hi, everybody. I'm just going to give you the same lesson that I showed in class, but a little bit more formal. So here is, lines can have positive slope. They can also have negative slope. Looks kind of like that. They could also have zero slope where they're flat and horizontal, or they could have undefined slope that's up and down. And that's because we can't divide by zero. We don't know how to do it. Those are your four options. There are no other options. But with calculus, what we're going to be learning about is, how do I describe the slope of this thing? Because it's got a bunch of different slopes. Over here, it's kind of negative. Over here, it's kind of positive. And something that we might end up wanting to know is like, what's the slope at that point, specifically right there? Yeah, and then I left it. It's somewhere over here. Sorry. Well, I don't think that's what I needed. Never mind. It's fine. And we could ask about different places, right? Like we could ask about it over here where it'd be kind of negative. Here it's a little bit more positive. Here it's zero, right? But I'm going to put this back at x equals 1, and we're going to care about that. To get that slope, what we're going to do is we're going to use a point that is a little bit bigger than that one. So here is my a little bit bigger than the orange point. Let's make that less projectory, and then you guys can see it. Okay, so that's what we're trying to figure out. I'm going to move me over here now. Cool. Here's how we can do that. We can use the triangle that's basically made by these 2 points, and the rise, which is that black distance, the run, which is that green distance that's kind of hiding behind the label here, and then the hypotenuse. Now, if you notice, the hypotenuse there is pretty close to the slope of the blue line. It's not perfect, but it's pretty close. And what we can do is we could calculate that slope right now. Right now, and don't worry too much about this, but it's going to come back later. The slope is 4. If I make that slope a little bit, if I make that triangle smaller, now notice you can barely even tell the difference between the blue and the orange. Now, if we zoom in super far, okay, they are still not quite the same, but it's getting really close, right? And the closer we get, we're like, well, there, clearly that orange line is pretty much exactly the same as the blue curve, but it's not perfect. And so you're like, well, fine, let's just take it all the way down, and then shoot, our slope is undefined. Make it a little bit bigger, and it's almost 2. And it's getting closer and closer to 2, but we can't actually get there. And the reason is that the hypotenuse, the slope, is the rise over the run. And right now, one of those is, well, they're both 0, but if you're dividing by 0, we don't really know what to happen. And so what we're going to be doing as we get into calculus and derivatives is we're going to be using this idea of making this smaller and smaller and smaller. And you can almost tell it's going to be 2 if only I didn't divide by 0. So I'll give you this graph. You can kind of play around with it if you would like. Let me know what questions you have.